Let's now recap translating curves. So moving basic curves around. Remember, a horizontal shift, well, that's when we replace the x, because horizontal is to do with the domain. So it's the x value that's changing. We replace x with x minus h, so it becomes function x minus h. That would result in a shift of h units, and depending on whether the number's negative or positive, whether we're going to the right or whether we're going to the left. If ever you're unsure to see where it's been moved to, just solve x minus h equals 0, and that'll tell you where 0 has gone to. Vertical shift, well, vertical, that's the range, so it's the y that has changed. So now y will be replaced with y minus k. Y minus k is function x, but we don't normally see it like that. We tend to see it where it's just y as the subject, but technically it's y minus k equals function x. And again, shift up or down depending on whether that number is positive or negative. We look at this, we go, well, our basic curve is the parabola. So y equals x squared. We're shifting it 3 units to the right, because that's the grouping with the x, and then we're shifting it up 4 units. And there's my new parabola. This one here, in order to see the shift, we can see it's going to be a circle because we've got x squared and y squared there, and the coefficients are the same. Now let's group them together so I can see the shift. So I'll complete the square on both the x and the y. We end up with x plus 1 squared plus y minus 2 squared is 9. So we start with our circle with a radius of 3. What have we done to it? We have a horizontal shift. We're moving that one left 1 unit. But then we also have a vertical shift, and so we'll move that up 2 units. And there's our new circle. 2x squared plus 8x plus 5. The first thing I'm going to do on that one is to divide everything by 2. And the main reason is because I just find it easier to complete the square of x squared rather than complete the square of 2x squared. So if I've got it as x squared, I can complete the square and I'll get x plus 2 squared. Now that I've done that, I'll then multiply everything by 2 to make it back to be y equals. Just how I approach that sort of problem. But now I can see what we've got. I've got my basic parabola, y equals x squared. I've got some sort of dilation happening here because of this multiplication by 2. So I know the curve's going to get steeper. There we go. We make it steeper. Now I'm going to shift it left 2 units, and then finally we're going to move it down 3 units. And that would be a picture for our new parabola. Okay, so that's just shifting horizontally and vertically, reflecting curves. Now we're going to replace with negative. Now, depending on whether it's a vertical or a horizontal reflection. Vertical be replacing the x, because if I'm reflecting vertically, it's the x values we're playing with. The y values will stay the same. We replace x with negative x. So it becomes y equals function negative x. That'll reflect in the y-axis. If I want to reflect in some other axis, what we're actually doing is combining then a horizontal shift along with the reflection. So actually what you end up doing is replacing a with 2a minus x. Let's show you what I mean. Why is it 2a and not just a? Well, let's have a look. There's y equals function x. If I was to reflect it, there's function negative x. Now if I was to shift that horizontally 2a units, this new curve over here is y equals function 2a minus x. If you look at the original curve that's blue and the one on the far right, that is a reflection in x equals a. And a similar thing happens horizontally. If I want to reflect horizontally, that's the y values we're now playing with. So I replace y with negative y, or we probably see it more as y equals negative function x. That'll reflect in the x-axis. But if I want to reflect in some other line, I'd replace it with 2a minus y. Again, same idea. Here's the original curve, y equals function x. If I reflect it in the x-axis, there's y equals negative function x. Now I'll shift it up 2a units. And again, we can now have a look at the reflection in the line y equals a. We've reflected it that way. When you've got a combination there of reflection and translation, you'll notice I did the reflection first. So you do the reflection before the translation. Reflection in the origin. That is y equals negative function negative x. So it's a reflection in both the x-axis and the y-axis. If you look at it closely, what that basically is our definition for an odd function. when we said function negative x was equal to the negative of function x. That essentially is what I've got there, just written a little bit differently. So we should end up with that rotation then of 180 degrees, just like an odd function. So let's start with the original one. There's y equals function x. I've reflected it horizontally, and then the last one there, now I've reflected vertically, and we get y equals minus function minus x. And if we look at the first curve and we look at the last curve, indeed, that's been rotated 180 degrees. Now let's try this one. Y equals minus x plus 1 cubed plus 2. So we start off with our horribly drawn cubic, y equals x cubed. Do the reflection before any translation. So I'll reflect, but I'm reflecting in the x-axis because that negative is not actually grouped with the x plus 1. It's grouped with the y. Remember, that's really saying minus y equals. So we reflect it in the x-axis. If it was the y-axis, then that negative should be in front of the x inside the parentheses, so it's grouped with it. So I reflect it that way. Mind you, when you think about it, for this curve, it actually didn't matter because if I reflect it vertically or horizontally, I'm going to get the same shape. Now I'll do the translation. I'm going to shift it left 1 unit, and then I'm going to shift the whole thing up 2 units. Y equals minus 2 to the power of minus x. Okay. Start with our basic curve. But you see we've got both the negatives being applied here. That means we've got the rotation happening. Okay. So this is reflecting in the origin. Well, reflect in the origin, and there we go. Okay. So 3G is what we'll do.